Okay, so here we have a reciprocal graph, and you can tell kind of what a reciprocal graph will look like. First of all, somewhere in the denominator you have a division by x, okay? So you could also have something that kind of looks like minus 7 divided by x minus 3. So sometimes there's just a plain x, and sometimes there's an x minus 3 here, okay? Or x minus 5 or x plus 7. But normally with a reciprocal graph, you're dividing by x somewhere in the function. So for this one, we have 8 divided by x. And they ask you to fill in this table. Well, that's quite simple. The first part should be easy. I will use one of these numbers as an example. Say x is equal to 1. So it's 4 plus 8 divided by 1 in this case. And if you do this, you should get 12. All right, so this point is 12. I can do one more. Y is equal to 4 plus 8 divided by, in this case, 2. And so that's 4 plus 4, so this is 8 in this case here. Okay, and if we go and look at some of the other values, we have for x is equal to 3, it is 6.67. I've got this down. For x is equal to 4, we have the value of 6. I'm using my calculator. For x is equal to 5, I get 5.6. And finally, we have the last value for x is equal to 6, which is 5.333. So let's plot these. Well, let's go to part B. Part B says use a graph of this from 1 till 6. So notice I've created my graph from 1 till 6. Okay, this is what this means here. You have to choose the appropriate values for x to graph this in. We don't care anything past 6 this way and underneath 1 this way. So our whole graph should look like this. So just a note, when we're graphing reciprocals, they should look something like one of these here. So notice they always have this line here, and then they get a break in between these, and then another line here. And they even have an example of what this looks like here. If you click on it, it's y is equal to 5 divided by x. So notice you're dividing by x again, and so that creates this reciprocal graph. And they have one part that they call the asymptote, where this line will never cross. So this reciprocal graph is not continuous. It has a break. And one of the things I told you, deadly rule, dividing by 0. So if x is equal to 0, that is impossible. So these lines get closer and closer to 0, but they will never cross them. Okay, and then here's some other ones that look like reciprocals. So you always have this sort of function where you have a half bathtub one way and a half bathtub the other way. This is kind of what we're looking for. But in this case, we'll see maybe we'll only plot between 1 and 6. So if we plot this, let's try 1, 12. So that is about right here. So 1 dot. Another dot is at 2, 8. So 2, 8, maybe out here. Another one is 3 and 6.67. So do I have 2, 4, 6, 8, 10? Oh, I drew that. This is 8 here. So that's 8, and this is 6. So we are at 3 and 6.67. So maybe about right around here. 4 and number 6, which is about here. And we get 5 and 5.6, so 2, 4, 6. So 5 should be somewhere around here. And finally 5.33 at the value of x is equal to 6, which should be right there. So this is a little bit of a strange graph. Notice that it has a curve. It's kind of curving down this way. All right. So what that's telling me is they've gotten us to plot maybe just a piece of this curve, like this slowly edging piece here. So they actually haven't gotten us to graph the whole thing or this whole piece here. They just wanted you to practice graphing this bit here, okay, which isn't so bad. So if I try and connect this together with my pen, which is going to be fun, it should look sort of like that, lower, and slowly more lower and lower like so. Okay, so there's my graph. So it says draw a graph of this. You just have to fill in your points and graph. The key thing is this thing. If they give you these restrictions, x has to be greater than 1 but less than 6, then you only need x is equal to 1 as your lowest point and x is equal to 6 as your highest point. And I've drawn this on one of the graphs of on the internet. And you can see this is what the graph actually looks like if we look at it together. All right, and if I zoom out, you can see the rest of the graph is exactly like what I was showing you there earlier on. You zoom in and it has this sort of shape this way and this way, but they've only got us to graph this little piece here. So that's an example of a cubic graph, just filling in the table of values and getting one of the slowly slanting bit here at the end.